demonstrated by sigma force with a vector arrow. Okay, which is the sum of forces. Right. So the sum of forces is equal to the net force, which is a combination of the forces. Net force takes place in a couple of different formulas, but they all mean the same basic thing. It's a combination of the forces. So the first one that you normally see, which is Newton's second law, is mass times acceleration. Right? So when an object has an acceleration, that means that there is a net force that is greater than 0 or less than 0. Okay? So when net force is not equal to 0, then there is an acceleration. Okay. So which means it's unbalanced, and the object accelerates. If your sum of forces is greater than 0, then it has a positive acceleration, which means it's doing what?
Speeding up.
Speeding up. If the sum of forces is less than 0, then it has a negative acceleration, which means slowing down. Okay. It's not going to go backwards because of the frictional force. Do you understand? Okay. All right, so then we have another equation for the sum of forces. Because all of our forces come in pairs, if it's an unbalanced force horizontally, then we are going to have the applied force minus the frictional force. The applied force minus the frictional force. This is the one you're usually going to deal with. If we're talking about vertical acceleration, it's Mr. Rochford. Then we have a vertical applied force, which is going to be subtracted from our force of weight. Okay. But in general, it's our frictional and our applied force. Now notice that these two variables are the same. So what I end up doing is I make these two formulas equal to each other. So my unbalanced force of my applied minus my frictional is now equal to my mass times my acceleration. Questions?
I didn't quite get that. So.
The sum of forces equal to the difference of the horizontal forces.
Mm-hmm.
It's also equal to the mass of my object times the acceleration in the direction of that force. Positive or negative. Right? Remember over there? My less than 0 is negative, greater than 0 is positive. So this is equivalent to this. Okay? Because my net force is just the sum of my forces.
Okay.
Okay? All right, questions on this? Ready for diagrams?
No.
Yeah.
It's very important whenever you're solving a force formula to make sure that you put your diagram correct. You do not draw a